Hey, hello everyone. So I'll just wait for some 5 minutes and then we can start.
Sir, actually, I have a doubt, sir.
Yeah. Right.
Sir, for the foundation level, recently I paid, sir, like registered, but in mail I got your payment is failed. So do I need to pay it again?
Okay, but it got failed, right? It didn't got deducted from your account or it got deducted?
Uh, in it didn't, sir. I didn't get
No, I was saying when. So the payment for what? For payment for what you were doing?
for quiz two, sir, like foundation level.
Okay, so the payment got failed, huh? So
Yes,
it
sir. Uh,
so it got deducted from your account or what?
no, sir. It didn't. I didn't get repaid from IIT Bank.
Okay. Repaid for what? Like I'm not able to understand what you're trying to say. Uh,
They sent a mail, sir. Your payment is failed. So do I need to pay again?
For what? For what payment you're doing? For what you're doing the payment?
For quiz two, sir. For foundation level quiz two. Like, yeah.
Okay, so you wrote the qualifier. After the qualifier, you'll have to pay for all the
Yes,
four
sir.
courses. Huh? This
Yes,
is
sir.
what you're saying.
Yeah, yes, sir. That's what I'm saying.
Hello. Give me 1 second. Hey, hello everyone. So yeah, so you were asking. Somebody was asking about the payment.
Yes, sir. Me, sir.
Is this the issue for all or just for you? Can somebody tell me whether anyone else was facing the same issue or?
Yeah, yes, I'm also facing same issue. I paid, but my that sorry, dashboard is not updated.
Okay.
I pay on 1st November.
Now, so you till now, did you pay it again or you have just? So one thing you can do is write to the support,
I
like they
didn't
will
pay
guide
again.
you.
Sir, I have mailed them, sir, like support.
Okay, so what did they say?
They didn't reply it, sir.
Okay, so what you can do is this is the only mail that.
Sir, in the dashboard also, it is showing that your course is registered successfully.
Hmm,
I can't get any QR code or payment form, sir, in the registration form. So,
okay, so this type of query support team only can handle. Maybe they are busy now, so they would not have replied, but they'll reply soon, I guess.
but
You
7th is
can.
the last date, so.
Okay, so I'm just writing my mail ID. You can just mail me. I'll just forward. That
Okay,
may
sir.
help. Yeah.
Okay, sir. Thank you.
Hmm. Okay. Can we start weeks? So we'll just do the thorough, like we'll just go through the content of week 6. Okay, we'll try to just finish it off today, and then in the next session we'll try to go through your doubts, whatever the doubts that you'll be facing. How many of you have gone through the lectures of week 6? So nobody has gone through the lectures of week 3, or sorry, week 6. Sorry, week 6.
Yes.
Okay. Okay. Some people has. Okay. Nice. So this week is like, I guess, one of the easiest week you can say. Here we are just going to discuss the logarithm function, mostly uh, the logarithm function with base e. Okay, even though we'll discuss the other logarithm function also, but mostly we'll be dealing with the logarithm function with base e. Okay, so I'll just try to share my screen. I hope this is visible to you. Okay,
Yes.
so my screen is visible, right,
Yes, sir.
everyone? Okay,
Yes.
okay. So in the last week also you have gone through the concepts of one function. Okay, and you have already read about the exponential function. Okay, how at least the graph of the exponential function. How does any graph, any function that is in the form of a to the power x, where any function in the form of a to the power x, where a is from 0 to 1 or a is greater than 1. Okay, so both will be having a different type of function, different type of a graph that you represent. Okay, and you already know the domain range of this function. Okay, any function, any exponential function with the base a, where a can be from 0 to 1. We don't take 0 or we don't take 1, because if you are taking 1 or a 0, that doesn't represent our exponential function. So that will be some constant function. 0 to power any value will, like, you don't know what value you'll be getting. Okay, mostly it will be 0, but again if you'll just be, it will be like infinite, so you don't know what value you'll be getting. And again, if you are taking 1 to the power any value, it will be in the form of some constant function, so that also doesn't represent our exponential function, right? So that's why we don't take 0 and we don't take 1. Apart from that, we can take any value for a. Okay, and depending upon the value of a, either it is from 0 to 1 or it is greater than 1, we'll be having a two different set of graph. I hope you're already aware of that, and you already know that this is a one function also. The best way, you can plot the graph and then check with the horizontal line test, and that will tell you that this is a one function. Basically, if you are able to backtrace the value, so if you are able to backtrace, then it's a one function. If you are not, then it's not a one function. Okay. So here also logarithm function is nothing but whatever you have read in the 50, the exponential function, just we are again reading the inverse of that exponential function. So logarithm is nothing but the inverse of your exponential function that you have read. So for any function, let's for example e to the power x, okay, that is basically a one function. When you take the inverse, so inverse is this function. So logarithm of, so how do you call log x base a? Okay, so if you have something like y uh, equals to e to the power x. So the inverse of this function is what? Log x base a. So this is how you represent. Okay, this is your x and this is your base that you call. So this is like pretty simple. Okay. So and if you're, so I hope you already know some of the features also. And last session also I told you, if you are just dealing with two functions, if let's for example fx is given and then you have been told that gx is the inverse, then you already know that fog and the gauge both will be what? X, right? So here also the same thing will happen. If you have to check whether both of whatever I'm saying is correct or not, you can check it. So how can you check it? So you can just put it like, what did I say? This, if this you're taking as a fx, so, and this as a f inverse x. So this you can try it out. F of f inverse or f inverse of fx, both should be x only. And those two are the most important properties also for the logarithm function. Okay, how does you get? So let's, for example, you are dealing with what? The function was a to the power x, and the inverse for this function was log of x base a, correct? So if you'll just try it out, if you're just putting this as fx and this as some function f inverse x or gx, whatever you want to call. So f of power of for this two will be x. Okay. So if we'll just put it of f of gx, correct? Our gx is logarithm function and fx is exponential function where a to the power x. Okay, we'll just try to put it a to the power all this logarithm function log a x. Okay, so this is the best method. You can just swipe this value also. There are some of the properties that we'll come to know also, and these two are basically a properties itself, because we already know that if both are inverse of each other, right? So this should follow for sure. So if that means what, this value should be x. Okay, and later you come to know that if you have been any value, if you have been given in this form, right, you basically swap the value. You swap the value of x and a. Okay, so if you are swapping the value, so that will become what, x to the power of log a log a base a. Okay, if you have been given log a base a, that is basically 1. So I'll tell you from the starting. So whatever I have told till now. So in the week 5, you have read about the exponential function, and you have already know that the exponential function, while drawing, whenever you were drawing, it was in the form of somewhat like this. So if you are just, where is this page? So it'll be in some form of such that you, the horizontal line test will pass every time. Okay, uh, for your function, exponential function, whether the value of a is between 0 to 1 or from 1 to 0. Okay, so, so that's why in this week we'll be reading about the inverse function of whatever we have read in the fifth week. The exponential function we have read. Now we are reading about the inverse function of that, and the inverse is the logarithm function. Okay, and in the logarithm function, if you have been represented in this form, y equals to log of x base a, this is simple. So this simply mean that the power, so what is the, so if you have been written in this form, y equals to log x base a, this simply means what is the power of a such that it will equals to x. Okay, the power of a, what is the power of, so this generally, if you have been asked to calculate this value, this simply means the power, what is the power of a such that it will equate to x. Okay, so let's, for example, if you have been given log 3 9, so this will be what, 2, because what did I say, the power of 3, what will be the power of 3? Okay, or how many times you'll multiply 3 such that you'll equate to 9. Okay, so you'll be multiplying 2 times. 3 into 3 will become 9. So that's why the value will be 2. Or if you have represented in this form, y equals to log x plus a, this simply means, if this is the equation, that simply means a to the power, you will multiply a y times, then it will equals to x. Okay, so a to the power y equals to x. This is what this means. I guess most of you already are aware of the logarithm function, so no need to go. So I hope you are able to get it. Now, the next part is what should be the domain and the range for this logarithm function. So whatever we have, and some information you already know from the inverse function also. So for any inverse function, for fx or gx, if both are like inverse of each other, then the domain of one function will become the range of the other, and the range of other will be same as the domain of the first function. Okay. And some other important features for logarithm function is, if the logarithm function is represented So if the logarithm function y equals to log x base a. So if you have to calculate the domain, the first thing that you have to check is this a can also be in the form of a variable also. So you already know that the value of a can be from 0 to 1. It can't be 0, it can't be 1. And a can be greater than 1. That you already know from the exponential function also and here also. So every time whenever you have to calculate the domain, you check for a also, for the base also, and for the argument also. So this is argument and this is base. Okay. So for x, what you have to check, this x should be always positive. Okay, this x or whatever the content here it is, that should the argument. So log of whatever the argument that has been given to you, base you can be given anything. So that argument should be greater than 0. Okay, it should not be equal also. It should always be greater than 0. When you will draw the plot, you'll come to know. Okay, if I'll just plot it out, maybe that will help you. So I'll just plot it from the inverse. Like there is some properties, right? If you have been given a to the power x, what is the plot of this a to the power x? If a is greater than 1,
Increasing
are there?
function.
It's an increasing function. If I have to, and you already know that if you have to plot the inverse function, so how will you plot? You generally take the reflection in y equals to x, right? Correct? So if you'll take the reflection, so if you'll just think of this line, whatever the asymptote it was there for y equals to a to the power x, it will come like this, right? And then it will go, you can just take the reflection and it will be somewhat like this, right? So this will be your y equals to log of x base a, where a was greater than 1. Okay, so this is how you calculate. You can you plot your graph if you have been given the inverse, like because you already know about the exponential function e to the power x graph, so you can directly plot log of x base a also, because from just to take the reflection for in y equals to x graph. Now, why did I say that this x or the argument should always be greater than 0? Because you can see that for this logarithm function that we have drawn, okay, you can see that what are the values that we are putting. So if you'll see, the values that we are putting is from where? 0 to infinite, right? It is, and you can see that the plot that is going, it is what? It's just the asymptote toward the y-axis also. So this is like, it's not touching anywhere. It's just parallel to that. After some point, it will be parallel to your y-axis, but it will not be cutting. Okay, so that means what? The value we are not putting, 0 we are not putting, and we are putting from 0 to infinite. Any value we can put in the argument, but it can't be 0. Okay, so that's why the argument, this was our argument for this logarithm function. So this x will always be greater than 0. Okay, that means the domain, what should be the domain of this function? 0 to infinite, correct? Are there? Are you able to hear me or not?
Yes, sir.
Okay. Okay. So for this function, you already know that for any function that has been given to you, the argument should be greater than equals to, not greater than equals to, it should be greater than always. It's strictly greater than 0. So it will be from 0 to infinite. So for any function will be, the domain will be from 0 to infinite. Now, can you tell me the domain for this function? What did I say? I just said that the argument will greater than 0. So for this function, what is the argument? Is it x or it is 1 minus x?
1 minus x.
Okay, so 1 minus x will be greater than 0.
Minus
Correct?
infinity to minus 1, not
So,
included.
correct. So x will be less than 0. So the domain for this function will be what?
Minus infinity to minus 1.
Minus infinity to 1.
Yes, sir.
Okay. Is this clear to everyone? Now, can you solve it for this question?
Sir, can you please explain it again, sir?
Okay. So I said it. For if you have been given a function logarithm y equals to log of x base a, so this whole argument, so whatever it is given here, okay, it can be given something like that, ax square plus bx plus c also to the base of alpha. So this should be your argument, and this value should be greater than 0. Okay, because you already know that the plot for any logarithmic function will be like this, right? That means it's not touching. So your x value is not 0 anywhere. So you can't put 0 here, right? So that means the whole value, this value should not be 0. So this will always be greater than 0. Okay. So that means from 0 to infinite should be the domain for any logarithm function. For our case, the argument is what? This 1 minus x should not be greater than 0. That means always be greater than 0. So this argument 1 minus x should always be greater than 0. It can't be equals to 0, right? It can't be negative for sure, because you already know that the plot, from the plot you can see that.
Sir,
Yeah.
may I ask a question? For every argument, it will be greater than 0 in
Yeah,
logarithmic function.
yeah, correct. But if so, argument you are able to understand. Argument means whole thing that is inside
Yes,
the
sir.
logarithm function.
Okay. Okay.
Correct, correct. It's not
So
about
if
x.
any argument given in this will be all time it will be greater than 0.
It will always be greater than 0. You can't put anything less than or equals to 0 in the logarithm function because it's not defined. From the plot itself, we can see that logarithm is not defined for any negative value. When it's not defined for 0 also, it's going somewhere minus infinite. Okay.
Okay, sir. I got it, sir. Thank you, sir.
Okay. Okay. Let's move to the next question. Okay. So can somebody tell me what's the argument here? Is it x or is it 1 plus x upon 1 minus x?
1 plus x
1
divided
plus
by
x upon 1 minus x.
Correct. So this value, this whole value should be greater than 0.
Greater than
Right?
0. Yeah.
1 minus x should be greater than 0. So you can solve it. What should be the value of x?
Greater than 1.
X greater than 1. Now, how do you solve this type of a question? See, if you can just, I don't know, there's a very simple method to solve, right? So there are two, for this, what are the roots for this? Roots or zeros, whatever you want to say. So one is minus 1, right? The other one, the one is not the root, but okay, so the one is one. If you'll just try to put one value that is greater than 1, if you're just putting one, let's, for example, you're just putting 100. So it will be 100 upon minus 100, like minus 99, something like that. That will not satisfy. So this area, any value, if you're just taking, this will not satisfy this equation. Okay. So that means this will satisfy, this will not satisfy. So your answer should be from minus 1 to 0. So the x value should be from minus 1 to 0. I hope you are able to get it. Whatever we have.
Actually, x is equal to 1 and x is equal to minus 1. Right, sir?
What?
X value will be 1 and minus 1, between 1 and minus 1.
Yeah, it will be
Minus 1 to 1.
minus 1 to 1. Minus
yeah.
1, correct. Even minus 1 will not be included or 1 will not be included. 1 to for sure will not be
Between
included.
minus 1 and 1.
Correct. So it will be minus 1 to 1.
Okay.
Is it clear to everyone or anybody has doubt?
So what will be the solution for this, sir?
This is the solution, right? X will belongs from minus 1 to 1. That will be the domain for this function.
Okay, sir. Okay, sir.
So for any function, if you have been given to calculate the domain, this is how you calculate the domain for a logarithm function. Okay. So any of the problem that we have solved, everywhere the base was simple. Base was some constant value. So that's why you need not to check about the base. But there can be some problem where they can give you the base also in the form of some xy. X. Okay. So what did I say? The x, whatever the base also you have to check. The base should be from, it can't be equals to 0, it can't be equals to 1. So it should be from 0 to 1 or it should be greater than 1. Okay. But for our problem, we taken any cases where the base is in the form of a variable. We just took all the cases where the variable is in the form of some constant value. So we just checked about the argument. We didn't check anything for the base, because base 3 is not equals to 0 and not equals to 1 also. So that's why we directly check for argument. We didn't check for the base. I hope that's making sense.
Sir,
Yeah.
sir, here why x is not equals to -1, sir? Why -1 is not including?
-1.
Yes.
If we put the value of -1, that will be 0. But log of 0 is not defined, right? If you put the value of -1, if you will
Okay,
just
sir.
put it.
Sorry.
Got it, right? Okay. Let's move to the next part. Okay, so now we'll plot. I've already shown you how to plot it, but let's try it out again. How will you plot it? Logarithm function of log. So here we'll try to plot it 0 to 1, and here we'll try to plot it for a greater than 1. What is the plot for y equals to a to the power x? If a is from 0 to 1, how does it go? Is it a decreasing function or an increasing function?
Decreasing.
Decreasing function, right? It goes somewhat like this. Now we just have to do what? We have to take the reflection in y equals to x. Correct? If we take the reflection, this is the asymptote to positive x direction. This will be somewhat like this, right? And this will cross. This would be the function y equals to logarithm of x base a, where a is from 0 to 1. Similarly, we can do further. For this, so we already have plotted. This will go somewhat like this. This is y. If we just have to take the reflection in y equals to x, we can take the reflection of that graph, and we'll be getting somewhat like this. So this is what y equals to log x base a, where a is greater than 0 or greater than 1. Here the a is from 0 to 1. That's the difference between those two. Now we'll see some of the features of this logarithm function. So now we'll just see that the first case, we'll just see this logarithm of x base a. Is this an increasing function or a decreasing function? This
Sir,
one?
excuse me.
Yeah.
Sir, for every concept, we need to check whether it is increasing or decreasing function. Is it mandatory to check it?
No, it's not mandatory to check the function is increasing or decreasing. If you have been asked, then only you should be checking. But I'm just telling you, for any logarithm function where the base is greater than 1, then that's a increasing function. You can see that, right? This is an increasing function.
Okay,
Correct.
sir. Okay, sir.
What are the other features that you can see? The domain for this function is what? From 0 to infinite. That's the one important feature. The other feature is what the x-intercept for this function. X-intercept is what? Where it is cutting the x-axis. So it is cutting, where it will cut x-axis?
1, 0.
1, 0.
1, 0.
Correct. Yeah, why 1, 0? If you'll just try to put the value of log 1 base a. So now what did I say? What should be the power of a? So how many times you'll be multiplying a such that the value will become 1? You already know that any value to the power of 0 is what? 1. So that's why this will become 0. Correct? So you're putting x equals to 1, you are getting y equals to 0. So that means 1, 0 is satisfying. So x-intercept is what? 1, 0. So it is cutting the x-axis at 1. I hope that's making sense. Okay. What is the y-intercept for this equation? Is there any y-intercept? Is it this
No, sir.
function cutting x? No, right? Right. So this will be there will be a vertical asymptote that will be almost parallel to your y-axis, right? This value, but it will not be cutting. It will not cut for sure the y-axis. Okay, and this function. So some of the properties I hope you already know. So some of the basic properties: the increasing function, it has x-intercept. It doesn't cut y-axis. It is like a parallel to y-axis. The domain for this function is from 0 to infinite. 0 is not included. What should be the range? What is the range for this function?
Minus
Range.
infinity to infinity.
Yeah, that's basically R, right? Any value you can have. You can see that y value can be any value. It can be any value, right? There's no restriction. So y value can be anything. Now let's deal with this function. Y equals to log x base a, where a is from 0 to 1. So this is a decreasing function. This was an increasing function. This is a decreasing function. The domain is same for both of the cases, right? From 0 to infinite. Range is also same, from minus infinite to infinite. That basically is R. What is the x-intercept? The same, right? X-intercept. Again, the y-intercept, there is no y-intercept. It's just, so only the difference is the asymptote for this is positive y-axis. For this case, this is negative y-axis. That's the only difference. Other than that, everything is same, right? For both, only the difference is like one is increasing, the other is decreasing, and the domain, range, everything is same. X-intercept, y-intercept, both of them doesn't cut y-axis at any point, right? Okay. This is the plot also here. It has been plotted. Some of the properties also it's written here. You can see that the domain for this function is from 0 to infinite. The range is R. The x-intercept is 1, 0. You already know that this is cutting 1, 0. Y-intercept, it's not cutting y-axis at all. So that's why it's nil. Then vertical asymptote, you already know that. So it will not cut or touch y-axis, but it will be parallel to y-axis, right? It's a 1, 1 function. Horizontal line test is passing, even though it's the inverse of your exponential function. So if you're able to find the inverse, that means a 1, 1. Okay. So for 0 to 1, if the a is like from 0 to 1, it's a decreasing function. And if a is greater than 1, then it's an increasing function. Okay. Okay. Now we'll try to draw this function. How can we draw? There are some properties. Okay. So I'll try to write some properties. For any, if we are some of the properties, if you have fx, plot has been given to you, and if you want to try f of minus x, what should you do in a graph if you have to plot? If you have been given fx and you have to plot f of minus x, what will you do? You'll take a reflection in x-axis, you'll take a reflection in y-axis. What will you do?
We'll take the negative values of x now. So we'll just flip y-axis. So x-axis.
Minus of fx.
Minus of fx.
We will take the symmetry line and then we will take the mirror image.
Symmetry about what? Y-axis, right?
Yes, y.
So you just have to take the symmetry about y-axis, or y-axis, you can just flip it off in the y-axis, right? Correct? Let's say I'm just giving you an example. This is y equals to ln x. How do you draw ln x? Ln x, I told you, right? This will be somewhat like this. If you have to draw y equals to ln of minus x, how will you draw? It will be somewhat like this. So you're just taking in a y-axis, you're just flipping the curve. Correct? This was y equals to ln. This is y equals to ln of minus x. Now the second property is, if you have been given fx, and now you have to plot minus of fx. How will you plot?
Reflection in x-axis.
Reflection in x-axis. Okay. So the same function, y equals to ln x. So ln x is what? Now you have to calculate, plot y equals to minus of ln x. It should be how? How it should be represented? It will be somewhat like this, right?
Yes, sir.
Now the next problem is, if you have fx, now you have to plot it f of x plus k. Now what should you do?
It will go up, upwards, k time
Upward or
k.
left side? Left, right, up, down. How will it go?
It will
Left
go
side.
up.
No, it will not go up.
Right,
So it will
right
see.
side.
It will go left side. See, if you have y equals to ln x, right? So it will be somewhat like this, right? If you have to plot y equals to ln of
What
x
is
plus 1, so it will be what? If this is 1, this will be like this.
When
You can
it
see
has
that.
dot
You
or
can see
minus.
that. Yeah, you can see that. See, this function, when this function was, the y value was 0, at what at x equals to 1, right? You were getting y equals to 0. Now for this equation, what should be the value? At x equals to
Here.
at x equals to which value your y will be equals to 0?
Minus
Sorry,
1.
X equal to 0.
not 1 minus 1. X equals to 1. Sorry, 0, right? You can see that. So that's why what. So just shifting this whole equation to left side, right? Left side of 1 unit. So this is what left movement of k unit. Is it clear to everyone? Is it clear or not?
Yes, sir.
Okay. Now the last property is, if you have fx has been given to you, fx plus k. Now what will happen? And the same thing you can do if you are doing a minus, then the right side movement. Okay, here if you are just minus doing the minus k, then so what will happen if you have fx and you are doing fx plus k? What will happen? It'll go up or down?
Up.
It is just shifting your y value, right? So whatever here it was fx, here it is what? Fx plus k, just shifting your y value up, right? So same thing, right? If you have ln x, so here it is ln x plus 1. So it is just shifting your whole thing by unit 1, right? So it will be somewhat like this. 1 unit shifting. Clear? Now, if you know 4 properties, the same thing. If you have minus of k, then k unit downward. If here it is minus, then k unit right side. Okay, I hope this is clear. Now let's draw this to plot. So here, what can you do? You already know what? Can you reach here? You know ln of x, basically log of x. You know log of x base 4. You already know the plot. Now what you have to do? X plus k, right? So from here you have to reach out to log of x plus k, 1. How will you reach? What should be the plot? Tell me the plot for this. This is simple, right? Just go like this. Now, what will happen here?
Left side.
Moves left by 1 unit.
Left side, 1 unit, right? Correct? So it will just shift
Yes.
left side 1 unit. Is it clear to everyone? Is it clear to everyone?
Quite not.
What?
How
Sir,
this is shifting left side?
I have a doubt how it's shifting to left side. It should be shifted to right side only when x get incremented. How it's shifting to left side, I can't understand that.
Okay. See, just tell me, if I'm putting for this function x equals to 1, what will be the value of y?
X is equal to 1, 1 plus 1, 1 comma 0. Okay.
Correct. Now for this equation, what should I put here such that I'll be getting y equals to 0? What should I put here? X equals to 0, right? If I'll put x equals to 0, then I'll get y equals to 0, right? So whatever we were doing here, so basically what we are doing, we are just shifting the x value by 1 unit left side, right? Correct? Earlier, whatever we were getting at x equals to 1, now we are getting the same value at x equals to 0. Are you
Okay.
getting me? Right? So that
Yeah.
means what? We are just shifting the value towards left side. Nothing. The same function, we are just shifting the value to 1 unit left side. Okay?
Okay, sir.
I hope, yeah.
Okay, sir. Thank you, sir.
Okay. So now if we are done with this, we'll just go to the second plot.
Sir,
Yeah.
if in this -1 will be the x value, sir.
What -1?
X value. If y is equal to 0 means this is x is equal to -1 is the value, sir.
No, no. Y equals to log of x plus 1.
Yeah.
Right? So if you are putting here x equals to -1, that will become log of 0. Log of 0 is not defined, right?
Okay, sir. Okay, sir.
So it should be log of 1. So to make it log of 1, you should be putting x equals to 0. Correct?
Okay, sir.
Yeah, so that's why. So
Okay.
earlier we were getting the same value at x equals to 1. Now we are getting at same value at x equals to 0. That means we are shifting it to left side, 1 unit.
Okay, sir.
Sir, if log of the x -1 means it will go right side?
It will go right side.
Okay, okay.
Now this equation. So this is simple, right? What did I say? If you have fx and if you want to draw f of -x, what will happen?
Flips and wax.
What?
Flip
In which
y-axis.
whether x-axis or y-axis? Y-axis.
Y-axis.
Yeah. Okay, so this you can draw it out. So this was simple. So the 4 properties that I told you, that is going to help you in the exam also. You can be asked which of the following represent this graph. Even though that's pretty simple, from the option itself, you can just take some values of x, some values of y, and from there you can directly take it by hit and trial. But if you know the properties, you can directly answer. Okay. Let's move to the next part. The natural logarithm function, the same thing. You just have to, in spite of a, wherever we were taking a as a base, we are just taking e as a base. Okay, e value is like exponential value that you'll read Euler's constant. That the value is 2.71, something like that. Here also, the function y equals to it is called x.
Sir, I have doubt. So log and ln same or different, sir? What is actually?
So whenever you're writing log, so the base, if you have been given the base as e, and then x, that is pretty like same as ln of x. So whenever you have just written ln of x, that means you have been given the base as e. So you have to, it's like it's already been given. If you have been written in this case ln of x, that means they have given you the base also as a e. Okay, but if they're written like this log of x, then they would have given you the base also. If not given, then you just assume it as a 10.
Okay.
Yes. Okay. Yeah, this is the difference between two.
Okay.
So anywhere if it is written like ln of x, that means it's a base e.
Okay.
And if log written, that means it's a base 10, because like normally we use log of x. Okay, directly if you have written 10 log of 10, that means it's equals to 1, because here the base must be 10. That's why they have not given. But if they have given ln of e, that means the base is e. Here also the value will be 1.
Understood. Then the properties of addition, subtraction, division, multiplication,
everything
all
will be same.
Common. Same. Okay.
Yeah,
Understood.
everything is same, because when I was plotting the graph of y equals to log x, right, base a, here what did I say? There can be only two categories, where a is from 0 to 1 or a is greater than 1. So for any function, for x natural logarithm function, what is the base? It's basically 2.71. That is greater than 1. That means it will follow all the properties for this case. Okay?
Okay.
Yeah. Okay.
Sir, why logarithms were discovered and what they use? What are their
earlier it
uses?
was discovered, I guess, I don't know why. It was discovered mostly for a large distance. If anything that is like, if like log
To
help us,
calculate
like
very big number in astronomy. Like
Correct. Yeah, if you have a very big number, you can represent with the help of log as a very small number. Let's, for example, you have to represent 1,000, right? Or maybe a very big number. So you can just represent that as a 3, like log 1,000 base 10 is what? 3, right? So this basically will help you to in the calculation also. So that's why it was discovered. Like that is what I know. Like there can be n number of reasons. Okay. So here also
But this,
everything
but
else
this
will be
log.
same. What?
Okay, sir. Continue.
Okay. Everything else will
I
be
guess.
same. The domain, range, everything else is same. Whatever we have discussed for the logarithm function, log of x base a, everything is same for ln of x also. The only thing here is what? The base is e. And e is what? A greater than, like e is greater than 1. So the all the properties of logarithm function x base a, where a is greater than 1, is same as for ln x also. The domain, range, everything. Even the graph also, if you see, the graph is also the same. Okay. So you don't have to confuse wherever. If you have been asked to calculate the domain for any function where the base is e, the same method you have to use. It's just that the base is given as a e, but we have read it for what? We have read it for any base, log of x base a. So anything can be given as a base. You just have to use the same properties. I hope it's clear. Okay, let's solve some of the problem now, and then we'll see the basic properties of the logarithm. There are some maximum 5 to 7 properties that we'll read. Before that, we'll solve some problem. How can you solve this problem?
Sixty-four we can factorize it.
2 power 6. X equals to 5.
We could expand the 64 as its exponential form and then just solve the exponents.
we can take log 2 base on both sides.
Yeah, that also you can take. Yeah, correct. So it can be solved in n number of like ways. Like you can
2 to the
take
power
the
6.
yeah that method also you can use it. You already know that 2 to the power what?
Exponential. Yeah.
Yeah, 6, and this is what to the power x plus 1. So basically
X plus 1 equal to 6.
Yeah, and how does it help us? So you can just take the log both sides. You can hit with log base 2. Okay, if you are just hitting with log base 2, log of base 2, here also log of base 2. If you have log of base 2 in the both side, what can happen? It will be
1.
directly x plus 1 equals to 6, right? So that will be x equals to 5. Okay. Is it clear to everyone? This was pretty simple.
That's
There's
clear.
no, yeah. So you can directly even write it like 2x plus 1, and then this is 2 to the power 6. This is what 2 to the power x into 2. So that will become 2 to the power 6, and then 2 to the power x equals to the power 5, and then x equals to 5. Because if you'll just hit it with log of base 2, you'll be having x here, and this side will be 5. So this was much easier. How will you solve this problem? Hit both sides. First of all, solve this one. If you solve, this is a properties of the exponent, whatever you have read it. So what will be the value? E to the power x square minus, sorry, not x square, it will be e to the power
Plus minus 3.
2x minus 3, correct? And this side will be log, sorry, e to the power minus x square. If you'll just heat both side with ln of, that means ln, I am saying that means you are taking the base as e. Okay, if you'll just heat it, it will be minus x square equals to 2x plus 3. And after that, you can solve it. That's a pretty a quality equation. You can solve it, right? You can get the value of x.
Yes.
Is it clear? Yeah.
Yes.
Now the next problem. How will you solve this? So this is not 2. This is 9 to the power x minus 2 into 3 to the power x plus 1 minus 27. How will you solve this problem? Yeah, till now, anybody has any issue with this? This both were pretty simple. Like if you have doubt, you can just ask me. Okay. If you don't have, we'll just move to the next problem. How will you solve this? Are you getting any idea how will you solve this?
Doing it as a
Can
quadratic.
expand. We can expand this
Better?
27 also, I think.
Yeah,
So 3
3 square.
Yeah, you can just no. Okay, I can take it as 3 square to the power x minus 2 times 3x plus 1 minus 27. Now what should I do?
Sir, that is 2 times 3 or 23, sir?
2 times 3. No, this is like written incorrectly.
Okay, okay.
How will you solve this? Are you getting any idea how will you solve this type of problem?
Expand the 27 with the exponential form.
What?
We can multiply 2
Expand
with
this
3
7.
and there. Yeah.
You can multiply what?
There's 3x plus 1. So we can multiply 2 with 3. So 6 keep our 6 into 3x.
Okay,
Yeah.
that's fine. 3 or 3x. Now what?
Minus 27. So we can also write this as 3x ka the whole square. So we can take 3x as x. So x square minus 6x minus 27. Yeah.
Now what should we do?
So
Is
we
it
can take
quadratic?
3x common na in this first equation.
Okay, that also you can do. Correct.
We can take 3x square. Yeah.
3x.
Sir, shall we take 27 as 3 cube?
Yeah, that also you can take minus 3 cube. Then only you'll be able to take the common, right? 3x plus 3 equals to 0. So it will be 3x equals to 9 and 3x. This is not possible, right? You already know that this is not possible. Correct?
Yeah.
Here it will be x equals to, again you can x equals to 2. So that's only one solution.
The second, third step, what is that?
Okay,
3.
or better, okay, that's the better way to do it is solve it in the form of a quadratic equation. Take 3 to the power x as t. Okay, if you are taking 3 to the power x as t, what will be the value of 3 to the power 2x? It will be t square. Correct? So that means what? This will
Sir,
become
how
t
come
square.
6.3 power x, sir? Can you please explain?
Oh, if you have been given 2 into 3 to the power x plus 1, right? How can you write this term? 3 to the power x times
X.
3, you can write it like this.
Okay.
So 2 into 3 is 6, right? Okay. So you can take 3 to the power x as t minus 6 into t minus 27. Correct? Now you can solve it, right? This is a quadratic equation. This will be t minus 9 and t plus 3 equals to 0. So what did I say? T you have taken as 9. So t equals to 9, right? But t you have taken, t is not our solution. X is our, x we have to find, right? So 3 to the power x equals to 9, right? Now x is equals to 2. So x equals to 2 is the one solution. Now the second solution we will get from here. That is t is what? To the power x equals to 3. This is not possible because we already know that exponential, minus 3, it's not possible. Negative value is not possible for exponential function, right? Because we already know that the domain for that function is from 0 to infinite, right? Any problem anybody has in this question?
So 0 don't have any exponential property na, because we can't raise it to anything.
Yeah, it'll always be 0. You'll be getting 0.
0 don't have any exponents.
Yeah, 0 don't have any exponent. See, in the calculus, if you read, if you just take 0 to the power any value, you'll be getting 0. But if you just think of 0 to the power infinite, that'll be a different thing again. But you don't read about, you don't take base as 0 or 1. Okay, this is what I was saying from the starting. You don't take 0 and 1 because that will not be an exponential function. That will be a different function. So for 1, it will be a constant function. For 0, it will be a totally different function. You'll always be getting 0.
We used to define the power of any constant that it's 1, and we can't define for it 0. You know?
Yeah, that's why we are not taking anywhere base as 0 or 1.
Yes, sir. Yes, sir.
Yeah. Okay. Any problem in this equation? Can we move to the next question?
No, it's clear. Yeah.
Okay. Let's solve this one. So till now, whatever we are solving, we're pretty easy. Now, how will you solve this type of problem? Because you can't hit both sides. Now you can hit both sides with the logarithm, but the base won't be same, right? Because if you are hitting both sides, the base should be same, right? It can't be like if you're hitting left side as a log to the base 5 and right side as a log to the base 3. That you can't do. You'll have to hit both sides with same base. Let's, for
ln.
example, so you can just hit it with a totally different base also. That also is fine. You can do it in that way also. So if you are just hitting with ln, so it will be what? X minus 2 ln 5, and this side it will be 3x plus 2 ln 3. Correct? And then you can solve it to get the value of x. If you are just solving it, what the value you'll be getting? So here it will be what? X of ln 5 minus 3x ln 3 equals to 2 times ln 3 plus 2 times ln 5. And if you're just calculating, x equals to what? 2 times ln 3 plus 2 times ln 5 by ln 5 minus 3 times ln 3. Right? So till now, whatever the problem that you are solving, it's like you're just hitting both sides with the value ln, right? And you're just using some of the properties. Nothing else you're doing.
Second,
Even though the
so
properties we have not read it yet. Yeah.
So second step, not understand, sir. So x minus 2 ln 5 below, how you are converting, sir? So x into
This you can
ln
write it
5,
like
x into ln
x
5.
minus 2 ln
Or
5.
you are this side you are bringing, so 2 into ln 5. Okay.
Correct. Okay. And how can I write this? 2 times ln 3. Can I write someone like, how can I write in a different way?
ln 9.
3 square.
ln of 9.
Yeah, you can write it here also. This 2 you can just put it here also. So that will be ln of 9 also, you can write it here. And for this you can just write it as ln of 25 also. Correct? There are some properties that you will read now also. And if you have ln of A plus ln of B, what can you write here?
ln AB.
ln of A
Okay.
multiplied with B.
Okay, that we'll read it now. But okay, before that, we have already read about some of the properties. Okay, these properties we have already read. This is the new properties. It's not new. It's like same. That is coming from where? F of f inverse and f inverse of fx. This is the the most important properties of the logarithm function. With the help of these two properties only, we'll be coming up all the other properties that you read about the logarithm function. Okay, and this function, this both properties from where we are getting? This properties we are getting from the f of f inverse, fog and gof of x. Because you already know that if you have a function fx and gx, and if both are inverse of each other, fog and gof will equals to x. Okay, and this is what I was saying. If you have anything a to the power log of x base a, you can interchange this x and a. If you are interchanging, what will be the value that you'll be getting? X times log of a base a. This will be 1. So you are left with x. That is the first property. The second property is what? Log of a x base a. So this you can write it here directly. So you are left with what? Equals to x times log of a base a. And this again is 1. So you are left with x. Okay, these are only two properties that if you know, you will be able to solve each and every problem.
Can you pardon again this too?
Okay, the second step, the second equation.
Both. I mean.
Okay, so this we are getting from that equation. If you have function fx equals to a to the power x, and this is f inverse of x is what? Log of x base a. If you have been given something like that, you already know that f of f inverse is what? X, right? And f inverse of fx is what? That is also x, right? That's properties from the inverse. So the same thing we are doing here, a to the power x, right? A to the power x, f of f inverse we are putting. So a to the power log of ax. So a to the power, I'll just change the color. So a to the power log of x base a. So this you can interchange. This x, this argument of this logarithm and a you can interchange.
We
If
can
you are interchanging,
interchange.
yeah. So that will be what? X log of a base a, and that is what? 1. So that is how we are getting x. And from here also you can see we are getting x. Now the next thing,
Yeah.
log of a to the power x. So base, this also you can write this x directly here. Okay. So if you're just
Yes.
writing it here, that will be what? X times log of a base a, and that is 1. And this we are getting as x. Okay, that is from here, this equation. F inverse of fx is x. So I guess now it is clear, right? So anywhere,
Yes, clear.
so that is how we have changed. That is how here it was written 3 times ln of 5. What can you write for this case? I told you, right? This 3 you can write it here directly because e is the base here, right? So you can write this 3 here, right? So that will be what? Log of 5 to the power q e. Correct? This 3 you can write it here also, or you can write it here. Both places. Both are same.
Sir, will you
Yes,
explain the last to third property, sir?
This one?
Yes, sir.
What is here? So log of, see, for any function here, you already know that log of a base a is what? 1, right? So if you have a function log of x base a, this is y, right? If you are putting x equals to a, what is the value of y you are getting? 1, right? So that means what? X is what? A, and y is what? 1. So this is what it's.
Okay, sir. Thank you.
Okay. I hope this is clear, right? The properties are clear to everyone.
yes, clear.
Okay. Now there are 4 properties. These are the base for your logarithm function. These are the 4 properties. You must be knowing this. If you are not knowing, and in the exam also we'll be having at least 2-3 problems from the properties of the logarithm function. So altogether, I don't know how last session also I told you there are altogether 10 questions for the quiz 2. Okay. Each week almost will be having a good weightage, like equal weightage. Okay. So 10 questions. There can be some question will be having a subpart also. So they altogether will be 14 to 15 questions in 1 hour that you have to solve. So some properties, if you just know the properties, logarithm function, whatever the question from the logarithm it's there, 1-2 question, will be able to solve it very easy. If you don't know, if you are just proving there itself, even though with these 2 properties itself, you'll be able to solve it. But these all properties also is there in your mind to just quickly solve the problem. Okay, so from now, like from the starting, I told you the graph question, there must be a graph question, that for sure. So the 3 properties that we have discussed is important. One question similar to this, right? This type of questions can be there where you'll be asked to calculate the number of solutions. So for this question, can you tell me, even though I have solved it, what was the number of solutions? It was 2 or 1?
2.
1.
No, it was 1, right? The valid solution was what? Only one solution, right? T
Yes,
x
yes.
equals to 2. This was an invalid solution. So if you have been asked to calculate the number of solutions, you'll always be saying 1. Okay, but if you have been asked to calculate what is the solution, that is 2. The solution is 2, but the number of solution is 1. I hope this makes sense.
Can you repeat?
And then one question from the property. Okay. What I was saying is, you have been asked to calculate the number of solutions. So what is the number of solution? You are just getting only one solution, right? That is x equals to 2. The
What is
number
the
of
value of
solution is,
solution you're asking?
I'm asking
X
number
value.
of solution. Number of solution. What is the
Okay.
number of solution? So yeah, if you have been given ax square plus bx plus c, mostly the number of solution for a quadratic equation is what? 2. Correct?
Yes.
If you have been asked to calculate the solution, then you have to find the value of x. So here, if you have been asked to find the solution, that means you are asking about the x value. But they are asking, if they are asking the number of solution, that means you just have to count the valid solution. Okay, that's the confusion. So they can ask you a similar problem where you will be asked to calculate the number of solutions. So the next question they can ask you from the properties of the logarithm function. So there are some properties. I'm not going to prove it, even though we can prove, but there's no point of that. So you just should be knowing the properties. If you have been given log of mn, that means log of m plus log of n. Base can be anything. Similarly, if you have been given log of m upon n, that means log of m minus log n. if you have been given log of 1 upon n, that's same. Only the m value becomes 1. So if m is 1, that means this becomes 0, right? So that will be minus of log n. So with the other properties, this we have already know, right? I told you, right? Log of m to the power r. Okay, this r you can write it here, right? I told you, right? So this r times log of m. Base can be anything. Base is a, base is
Sir, will you tell a belongs to 0, 1 or a greater than 1? That
a
means
for anything, for anything. It's a should not be equals to 0 and 1. Other than that, a can be from 0 to 1 or a is greater than 1. For all the cases, the properties will be same.
okay, sir. Thank you.
Okay, but a can't be 0 and a can't be 1 because we already know that from the exponent itself, because we were not taking a as 0 and we were not taking a as 1, because that was not even a exponential function, that was a constant function. So that's why here also sorry,
That means in open brackets, we shouldn't consider that value, right, sir?
yeah, that is why it's written as open bracket.
Okay.
You can't take 0 and you can't take
Okay.
clear with everyone. And yeah, this also you should be knowing. This is not log of m plus log of n is nothing. Okay, log of m plus log of m plus n is nothing. You can't write it like this. You can just prove it as log of 10 plus 10 base 10 is not log of 10 plus log of 10. Okay, this is what? This is 1, this is 1. Okay, this is a different value altogether. Log of 20 base 10 is not 2. Okay, this is not equals to 2. Okay, if it was log of 10 multiplied with log of 10, then you would have written like this, log of 10 plus log of 10. This is 1, this is 1. And you already know that log of 100 base 10 is what? 2. So this is correct. But this is not correct. Okay, this should be there in your mind. Okay, that's why it's written as a note. It should be there in your mind. Okay?
So,
yeah.
This logarithmic properties as log is related to exponents. So as same, this logarithmic properties are very much similar with the exponential properties that we have studied.
Yeah, it's whatever you are reading there as a base, as a domain, here you are just reading as a base. Okay, and the same property, whatever the value that you are taking for a, because it's the inverse function of that, right? So whatever the a value that you are taking there, the same value you are taking here.
Just notations are different. Everything is same.
Okay. So now the same properties, all the properties we have already dealt with, just the proof, no problem here. Okay, let's try to simplify this equation. How will you simplify? You have to help me in simplifying this equation.
First take log of m by n. So log m minus log n.
Okay, so that will be what? Log of x cube root of x square plus 1 minus log of x plus 3 to the power 4. Now, what should I do next?
And log of mn equals to log m plus log n in first case, like log of x cube plus log of root of x square plus 1.
Okay. Log of x cube plus
log
of root x plus 1 minus log of x plus 3.
So here you can write 4 into log of x plus 3.
Yeah, we can write this 4 here. Correct. What should I write for this case? Here also 3, I can write it here.
Yes.
What should I write for this case?
1 by 2 into log of.
Correct. Yeah, I can write it like this, x square
plus 1.
Anything else can I do? 3 log x, 4 log x plus 3. Any more simplification? Can I write here like this? 4 times log of x plus 4 times log of 3. Can I write it like this?
No, sir.
No, we can't write it like that. Okay, so is it? Yeah, so we have done the simplification. Anybody has any issue? I don't think so. Okay, let's simplify this. Now we have to combine this. What should I do? Can I write 2 here directly?
Yes, sir.
Okay, and then I can directly multiply both.
Yes,
so
sir.
it will be
9x
what?
squared into x squared plus 1.
9x square, correct? I can multiply this also, right?
Yes, sir.
x square plus 1. And then
Divided
can I
by
divide with 5?
Yes,
I
sir.
can divide it by 5, right? So it will be okay. It's done. Now there is only one property that is left. That's the change of base rule. Nothing else is been left here, and this is wrongly written here. If you have been given log of x base a, you can write it directly as log of x, because x is here, you can write it x here. A is here, you can write it a here. Log of a. You can take any base here, b. I have taken b. You can take anything else. Okay. So if you have log of x base a, you can directly write it as log of x upon log of a. Base you can take anything. I have taken b. This is the change of base rule. If you don't want anything in the form of base a, you can convert that in the form of base b also. Base c, d, anything. Okay, this is how you change the base. Okay. See, let's for example here, and there was a reason for that also. If you have been asked to calculate log of 89 base 5, because in the calculator you don't have base 5, even though you can calculate it, but the normal calculator will always be having natural exponent, natural logarithm function, or in the form of a 10. So what you can do is you can directly convert that in the form of a 10 or base. How can you do that? I told you log of x base a. You can directly write it as log of x upon log of a. Base you can take anything. So here also 89 here, you can just write it as log of 89 upon log of 5. Base you can take base here, you have taken e, you can take anything. Okay. And this is also a warning. This you can't write. Log of 10 upon 2, you can't write it as log of 10 upon log of 2. This you can't write. Okay.
Okay, sir.
Okay. So now let's solve some more problem, and that will be it for our logarithm function. After that, whatever the doubt that you have, you can solve it. Let's solve it. Okay, how can we solve this? You have to prove that 1 upon log of pi base 2 plus 1 upon log of pi base 6 is greater than 0. Greater than 2. You have to use change of base rule. How will you do that? Okay, how can you write?
After changing, it will be log of ln 2 divided by ln pi plus ln 6 by ln pi.
Yes, sir.
Okay. So it will be ln
Log 2 by log pi
log 2 by log pi
plus log 6 by log pi.
ln 6 by ln pi. So this
So
is
what's
what
the difference between log and ln?
I told you, right? If you are writing log, so you should have been like if you have been written log of x and ln x, that means here the base is e, here the base is 10.
Okay, sir, thank you.
Okay. If they have written log of x base 5, if they have mentioned the base, that means the base has been given already. If they have not mentioned, and if they have written in the form of a log, then you have to assume that the base is 10. Okay. And if they have written ln, that means you have to assume that the base is e.
So can we directly change from log to ln? You have just did here, sir. Right?
Yeah, you can change it.
Even the bases are different.
You can, yeah, you can change. See, if you can change it from any basis to other basis. But this has been done, change of base, because let's, for example, you have been given in the form of log x base 3. But you have to calculate some, let's, for example, here it has been given some 75 there. Now you can't calculate with the help of your calculator, because the calculator, you can put the argument in the form of base e or base 10. Right? So what you can do is you can just convert that in the form of a base 10 or base, and then you can calculate. How will you calculate? Log of 75 upon log of 3.
Okay, sir.
Okay.
Okay, sir.
So
thank you.
yeah.
Sir, we can take pi as base also.
You can take pi as base also. Yeah. Anything you can do. You can take pi as also base. If you'll take pi as a base, it will be what? It will be log of 12 pi square, right? Greater
Yeah.
than 2. Not pi square, what I'm writing.
Pi.
Pi. What is the value of pi square? Pi square is somewhat 10, right?
Pi square. Yeah. Yes, sir.
Yeah. So that means it must be greater than 2.
Sir, will you explain me this thing, sir? 12.
Okay. So what he told, so we can anything if it has been written in the form of log pi 2. So with the help of change of base rule, can I write it like this? Log of pi upon log of 2. Base I can take anything, right? If
Yes,
I
sir.
can take anything, why can't I take pi itself? If I take pi, it will be what? This will be 1, right?
Yes, sir.
Correct? So this will become what? This 1 upon log pi base 2. So that will become what? 1 upon
Log 2.
log of 2 base 2. Correct? So this
Yes,
will be
sir.
what? It can go directly here. So this will be this will change into log of 2 base pi. Similarly, for this case, it will be log of 6 base pi. Correct? You already
Yes.
know that the basic
Yes, sir.
formula, properties of log of A plus log of B.
Log
That will
mn.
become log of pi 2 times 6. So it will be 12.
Thank you, sir.
Now, you already know that what is pi square? Pi square you would have read like it's like somewhat equals to 10, right? So here it is 12. That means it must be greater than 2, right? This value must be greater than 2. That is what we have to prove. Got it, right?
Sir,
Yeah.
I got doubt. So, how your inverted, sir? So log base 2 pi. How you converted to log base pi 2?
Okay. So this step you got it right. This step.
Yes. The below one you yeah. So this step 2 base 2. How you are converted this? Yes, correct.
Now, this step you're asking.
No. The what you
This
circled.
one.
So circled one only.
Okay. See. So if you have to convert log of pi base 2, if you have to change the base, how do you change the base? Log of pi upon log of 2. This is how you write. Base you can take anything, correct?
But I don't know, sir. This property maybe I'm new actually. That's why I'm thinking. So
this
base.
properties we have read, right? Log of x base a is equals to log of x upon log of a. Base you can take anything.
Okay. So maybe this property I'm new actually. Now
No,
I'm seeing.
just now I read.
Okay.
Like just now we have read, right? Here itself, change of base rule. Log of x base a, you can directly write it as log of x upon log of a. Base you can take anything.
Okay. So we can convert the base. Okay.
Correct?
Okay.
So if you are base, you can take anything. If you can take anything, why not pi itself?
Okay. Understood.
So this will be 1. So it will become 1 upon log of 2 base pi.
Understood, sir.
Okay, I hope this, yeah. Anybody has any doubt here? Okay, let's move to the next question. How will you solve this? You have to solve this equation and tell me the value of x.
X square equal to 4. And x
You can
equal to
directly,
plus or minus 2.
this you can write it here directly. So you'll be left with what? X square equals to 4. So x will be plus minus 2. Anybody have any doubt? You can directly write this 2 here, right? So you will be left with what? You will be left with log of x square base of 0.5 equals to log of 0.54. Correct? Now it's like simple, right? X square equals to 4.
Yes, sir.
Okay. Now you have to tell me, find the number of solution for this example.
1.
What is the 1 or 2?
1. We can't
2,
take
sir.
minus.
Plus or minus 2. Okay.
Can we take minus 2?
Minus 2 you can't take, right? Because you
Yeah.
can't put the value of here. X can't be minus, right? X can be negative here. Because you already know the domain of any logarithm function. Okay, so if you can't take minus 2, that means the number of solution is what?
1.
Only 1. Yeah. But the solution is 2. The number of solution is 1. Okay, I hope this makes sense.
Sir, what's the
Now,
conclusion for the above questions, sir? Like log of
this
12
question,
base by. Yeah.
yeah, we
Yes.
have solved it, right? Log of, what is this? So log of,
12 base by.
so we
12
were
to
left
the.
with log of pi 12, right?
Yes, sir.
So this value, pi is what? Like pi is somewhat around 3.14.
Yes, sir.
If you'll do the square, maybe you would have read in physics that pi square was equals
10.
to gravitational value. So 10, right?
Yes, sir.
Correct? So pi square is somewhat 10. That means this value would be what? Greater than 2, right? Because if it was log of pi 10, then this was around 2. It was approximately 2. But if it is 12, that means it is greater than 2, right?
Yeah, okay, sir. Okay.
Yeah, that's why it's greater than 2. So that is what we have to prove, right? We have proved it.
Thank you.
Now solve it. This question, this, yeah. So we are this is the last, second last problem. After that, no, we have some more questions. Okay. So try to solve this and give me the number of solution and give me the solution. This is very simple, right? What can you write? This is log of a plus
X
log of
square
b.
equal to 2.
X plus 1 into x minus 1.
X square minus 1 is equal to 8.
X square minus
is
1
equal
equals to
3 minus 3.
This is log 8 equals to 1. So how can you write it like this? How can you write this equation as x square minus 1 equals to 8? Correct?
Yes, sir.
This you already know, right? If you have been given log of x base a equals to y, how do you write? You write it like 8 to the power y equals to x. This is how you write. Correct?
Yes,
So
sir.
for this equation also, you write it as 8 to the power 1 equals to x square minus 1. So x square equals to 9. So you have x equals to plus minus 3. Now tell me how many solutions for this equation? Is it 2 or 1?
Number of solution is 1.
Number of solution is 1 because x equals to minus 3 you can't put. If you'll put here minus 3, this will be like the domain will be like negative. And here also minus 3 you can't put. So 3 is the only solution for this case. Is it clear to everyone?
Sir, I lost in first step.
Okay. So okay. So log of a plus log of b. What do you write?
Log of AB. So if the base is same, we can multiply A into B.
Yeah. You can multiply. Okay. Are you able to hear me now?
Yes, sir.
Yes, sir.
Is my voice audible? Okay. So yeah. So if you have log of a plus log of b, base can be any, like base can be anything, but must be same. Then what can you write here? Log of ab, right?
Yes,
Are you
sir.
there?
Yes, sir. Yes,
Okay.
sir.
So for the same thing, for this equation, you can write it as x minus 1 and x plus 1. Base as 8 equals to 1. And this type of equation, how will you change? The next step should be 8 to the power 1 equals to x minus 1 and x plus 1. That will be what? 8 equals to x square minus 1. So x equals to plus minus 3. But again, minus 3 will not be answer because you already know that here, if you will calculate, okay, calculate the domain of this function. What will be the domain of this equation? What will be the domain of this equation? This equation, y equals to log of x plus 1 and plus log of x minus 1.
X square minus 1 greater than 0.
x minus x square minus 1 greater than 0. What will be the solution?
1 to infinity.
What?
We can take 1 to infinity as domain.
Yeah, so it should be x minus 1 into x plus 1 greater than 0. This will be minus 1 and 0. Sorry, minus 1
Sir,
and 1.
greater than or equal to 0 only, right, sir?
No, here it will be greater than 0 only. It should not. So 0 you can't take, right?
No, normally we'll tell for the range for a
No.
numerator portion, it's greater than or equal to 0, right?
For those cases you do. For logarithm function, if you have been given log x, because the plot is what? The plot is like this, right? You can't take x equals to 0. X equals to 0 is not defined for logarithm function. So that's why you can't take x equals to 0. You'll have to take x greater than 0 always.
Okay.
Yeah. So what is the domain for this function? So this will come, right? This will not be there. This will be there. So minus infinite to minus 1 and 1 to infinite.
Yes, sir.
Sir, will you tell how to calculate the domain of logarithmic functions once again, please? As I didn't there.
Okay. See, for this equation, it should not be minus infinite to minus 1. Why? Can somebody tell me why minus 1 to minus infinite to minus 1 we can't take?
Because log x minus 1 is not defined in minus infinite to minus 1.
No. See,
No,
there is a
the
difference.
value cannot take 0.
See, if you have been given y equals to logarithm of x plus 1 plus logarithm of x minus 1, and if you have a function given y equals to log x square minus 1, what is the so the domain for this two functions will be same or different?
Different, I think.
The domain will be different, right? Even though it looks like same, but it will be different. Okay, but do not get confused. I'll not be confusing you. So let's, for example, I'm just asking you to calculate the domain of this function. You have been given like this. Now calculate the domain. What will be the domain for this function? For this
Minus
function, the
infinite.
domain will be minus infinite to 1 and 1 to infinite.
Minus 1 to infinite.
Minus infinite to minus 1 also you can take, because if you just try to put minus 1 to minus infinite to minus 1 open, and here also from 1 to infinite open, you can take any value. Let's, for example, you're taking minus 2. If you just put minus 2 here, what will be the value? Minus 2 ka whole square plus minus 1. So this will be what?
3.
3, right? That is what? It's defined.
Yes.
Correct?
Yes.
But if you have been given like this, log of x plus 1 and then plus log of x minus 1. For this case, you can't take minus 2, right? How can you do minus take? You can't be saying that, okay, I'll just simplify and then. No, it doesn't work like that. If you have been given a function like this, then you have to check it for this function itself. That means you have to check it for this case, and take the intersection. Are you getting me?
Yes, sir.
Yeah, so this is how you calculate the domain for any function. So for any logarithm function, so let's, for example, it is like this, right? So what did I say? So the argument, this is your argument. Whatever inside the log, that is your argument. That argument should be greater than 0. It should not take 0. It should be greater than 0. Only not greater than equals to. So that means x plus 1 greater than 0. So x is greater than minus 1. So minus 1 to infinite should be the domain for this function. Minus 1 is not included. Okay. So for any logarithm function, whatever has been given to you, whatever the argument, so argument can be, so log of the argument can be ax square plus bx plus c. This is your argument. So this value should be greater than, so ax square plus bx plus c greater than 0. Whatever the x you will be getting from here, that will be the domain for this function. Okay, is it clear to everyone?
Yes, sir.
Okay. So now you solve it for this equation. Solve this equation. That will be, I guess, the last equation, the last question for you. What will the value of x you'll be getting for this?
Sir, I am getting E square.
Only one solution? One solution, so I can directly say x equals to 1. X equals to 1 is a solution for this case. Right? X equals to 1, if you'll put, you'll get 0, 0 both sides, right?
2. X
So
is
one
equal
solution
to.
I can directly, even E square also is the solution for this. So how many solutions you are getting? 2
Sir,
solutions.
I'm getting 2 solutions, but 0 is not applicable in this.
Sir,
So
is
2.
it trial and error method?
No, it's not hit and run. And directly I can say 1, if you'll just put x equals to 1, you are getting the solution. So how will you solve this? Okay, you can write 2 here, you can write it like this. 2 ln of x equals to. Can you write 2 here?
No, sir.
You can't write like, right? So this will be what? Ln of x ka whole square. Now what you can do is you can just take ln of x equals to t. Now do solve it. 2t equals to t square. That becomes t square minus 2t equals to 0. So t is what?
T is equal to 0.
And t equals to
2.
2. But 0 is not a solution. We have to find the solution for x, right? So we have to equate it ln of x equals to 0, right? So what? X will be equals to what? 1. One solution. Now the second thing is ln of x equals to 2. That means x equals to e square. So this is the first solution. This is the second solution. How many of you have understood this?
I don't understand.
Okay. So can you write 2 here? You can write, right? So 2 times ln of x equals to ln of x ka whole square. This 2 you can't write. I hope this is clear to you. Now what we can do is we can just take ln of
ln x equal to t.
Even though without taking t also you'll be able to solve it, but just for simplicity we are taking ln x equals to t. So if we'll just take 2t equals to t square. That means t square minus 2t equals to 0. T equals to 0 or 2. Correct?
Yes.
Okay. So now ln of
Cannot take 0.
x equals to 0. That means what? X equals to 1. The next solution is ln of x equals to 2, right? E square equals to x. These are two solutions that you are getting.
This last I don't understand. ln x
Which
equal
one?
to 0. ln x equal to 0. X equal to 1. How it's come?
Because base
No.
is e.
No. So how do you solve? E to the power 0 equals to x, right? This is how you write this equation, correct?
Okay.
So x equals to 1, right? Similarly for the other case, ln of x equals to 2. That means e to the power 2 equals to x.
Oh, got
because
it.
you have to calculate the value of x, right? So that's why these are the two solutions that we have. Is it clear to everyone?
Yes, sir.
Okay. Any other doubt that we have discussed? Anything else that you have, you can just ask me. Yeah, this also is left. Just solve it, this equation. This is pretty simple, right? How will you solve this?
Sir, we can write them as log 3 base x.
Log x upon log 3 log x upon log 4 equals to 4. Correct? Now you can take log x is common, 1 upon log 3 plus 1 upon log 4 equals to 4. Correct? And this you can calculate it, right? From here you can calculate directly. Log of x times, this will be log of 4 plus log of 3 upon log of 4 times log of 3 equals to 4. Now what you can do is log of x will be 4 times log of 3 into log of 4 upon log of 12. Correct?
Yes,
Are
sir.
you
Then
able
we
to
can
understand?
simply,
Yeah. Now what you can
yes, sir.
do is, whatever the
The
base that
power
you have
e
taken,
to the
if you have
power.
taken 10, then 10 to the power this whole value will be x.
Yes, sir.
Correct? Have you understood? This was simple, right? You just have to change the base and then x, put x in one side and the other, all the other thing at the other side, and then use the properties of the law.
Sir, can we use ln to find the value of a specific number in our exam calculator?
Yeah, ln you can take or log you can take. From both the you'll get the correct answer. But
Oh, okay.
yeah, change, if you are using the change of base rule, use it nice, like wisely. You can't be using, you have to use the base at all the bases, like all the places you'll be using the same base. You can't use
Yes,
it
sir.
for half. Yeah, so then only you'll be getting the correct answer.
Okay.
Sir, now what's the x value, sir? X equals to 10 power 4 into log 3 into log 4 by log 12.
Yeah, 10 to the power the whole value. Let's, for example, this is y. 10 to the power y equals to x. This is the y value, the whole thing. The whole thing is y.
Okay, sir.
Yeah.
A little up, sir. Little up, sir.
Okay.
Okay. So here, okay, based on the property change base property written. So log 4 plus log 3. So in this, what is the base, sir? Actually, what is the base exists here?
Base you can take anything. Here it is
Anything.
10.
Okay. So
Anything you can take.
by
If
default, we
it's
can
not
consider
written,
10. Okay.
yeah, if it's not written with log, if it's written, then you have to take base 10. If it was written as ln, you would have taken e as a base.
E. Understood, sir.
Correct.
Thank you.
Correct.
Sir,
Yeah.
sir, we can write 1 by log 3 as log 3 whole power minus 1.
What?
1 by log 3 as log 3 whole power minus 1 means minus 1 into log 3, no, sir?
No, I didn't get you.
Second step, 1 by log 3 means minus 1 into log 3.
Minus 1 into log 3. No, that is not correct.
Why?
See, why? Because see, if you have been given log of x to the power whole square, can you write it like this? 2 log x?
No, sir.
No, right? So here also, log of whatever 3 to the power minus 1. Can you write this minus 1 here?
No, sir. Okay.
Yeah. Right? So that's right. Anybody has any other doubt in the logarithm function? So we have discussed all the things about the logarithm function. You can just go and try all the problems that is there in the activity practice everywhere. Try to solve it. You'll be able to solve it all. If you're not able to, just send me the questions, or maybe in the next session when we'll meet, we'll try to discuss all the doubts that you have. Maybe that will happen, I guess the next Friday or Saturday it will happen. So in that session, we can ask, or maybe the TA session that is happening regularly, there also you can ask the doubt. Any other doubt, that anything that you have, you can just ask.
Can you
Sir, I
show
have a
this
doubt
question
in
once, Ram?
Week-6 graded assignment.
Which question?
No. Last question which you solved.
Yeah, this one.
Yeah. So down. Just come down of this question.
This one, right?
Yes. The next step after I couldn't see. I want to take. Yeah, this one. So how you are concluding this as y equal to x?
Y equal to x. Huh? Which y?
Then y. Okay, the
Okay.
whole thing you took as a y.
Correct. The whole thing is y. Okay, sorry, I deleted. So this whole thing is y. So 4 times log of 3 into log of 4 upon log of 12. This whole thing is I'm taking. So this will become x equals to 10 to the power 4 times log of 3 log of 4 upon log of 12.
Sir, what
So
if they
till
ask?
this is fine, right? So after that they won't ask you.
What?
till this is the last solution. After this, we don't want to
No, they won't.
find more.
No.
No.
Sir, what
They'll
if
just
they ask in logarithm function find the range of following
range.
function?
Mostly they won't ask, but it depends on the question. So range calculation is the most difficult part. It depends on the question rule. Like domain, there is a basic formula, right? It should be greater than 0. For range, you can't, because range can be any value. So that depends on the question to question.
Okay, sir. Thank you.
If we can change this log as a exponential, then we can find the range, whether it is a exponential domain. So that can we conclude it as a range of logarithmic?
The range of a logarithm is a domain of exponential.
Yeah. So we can convert into the exponential,
but that
and then
is like,
finding that term.
no, if the function is very complex, then you can't, right? If the function is pretty simple, then you can. But
simple, you can, yeah.
But the function won't be like, your argument will for sure will be in the form of some chord equation. That it is very difficult, yeah.
So the exponent,
the given function will always be in this form, y equals to some logarithm of x square bx plus c in this form.
Yes, then it is
So here
tough,
it becomes very difficult. So that's why it will depend upon question to question. Mostly if they're asking the range, mostly it will not ask, first of all. If they're asking, maybe it can be in the graded and practice, that's fine. But in the exam, they won't be asked.
So what would be the expectation question in this logarithmic, so we can expect?
I told you, right? 3 questions. So I already told. One can be from the graph that I told you, the properties you should be knowing for sure. One question is like, there can be question, they'll be asking you to solve this. Give me the number of solution or the solution itself. Or the third problem will be from the properties of the logarithm. So 3 questions for sure will be there. And in the similar fashion will be there. Okay. So you'll have to practice this type of problem. Yeah.
Sure. And can you share this PDF also to the chat box? With the written only is enough.
Chat box.
Or a supplementary content also fine.
I can share. There I can upload it. Yeah, there I can do it. Okay. Anything else from your side?
I joined very late. Today it was a summary for week 6, is it?
Yeah, it was a summary for week 6. So we have discussed all the things from the week 6. But any other doubt, anything else, you can. I already given you the mail ID, discourse. You can put like wherever you want to. You can just discuss. So what like you can do is just try to solve all the activity question and the practice questions, some of the practice question, because some are really difficult, the practice questions, and then try to like submit the graded. And the most important thing is to solve the previous term paper from wherever you are getting this, like the questions from this week. Please try to solve all the previous term, at least not all, but at least 2-3 terms. So each term will be having some 2-3 questions. We'll be having altogether 5, 10, 15 questions. Try to solve it. You'll get an idea which type of problem is asked. Mostly the questions, similar pattern of the questions will be asked. But then also, I don't know, like mostly this I told you so many times that try to finish the previous term paper. Then also, if I'll just trace back the previous, like the quiz paper also, more than half of the paper you can find it similar problem in some of the quizzes. And then also the passing percentage that I saw was around 35% for the qualifier, and then for the foundation it was around 55. That's not even like, that's very not good. Yeah. So I just expect you to solve the previous
going to be
paper
from 5 to 8, right?
What?
Quiz 2 is going to be from week 5 to 8 only, right?
Yeah, week 5 to 8 only.
Sir, week 5 to 8 या फिर week 1 to 8?
5 to 8. For Maths 1, it will be 5 to 8.
So no, not from 1 to 4.
1 to 4 there won't be, but the concept can in some of the questions the concept can be used like set theory or like, but you can't say that is from week 1 to 4. There won't be, like I have seen the paper, there is nothing from week 1 to 4. And in Maths 1, like there's nothing from week 1 to 4. Okay, for the in term, I'll guide you from which weeks the weightages are high and low. But for quiz 2, you just have to prepare from 5 to 8. That's it. I don't know about the stats and all, but for maths it will be from 5 to 8.
Oh, thank you. Okay.
Thank you very much.
Sir, I have a
So
doubt, sir.
so if we miss any graded assignment, then what happens?
Nothing. You just have to submit, I guess, 9 or 10 out of 12. So if you're missing something, that's fine. Like that's not fine, but you should not be like missing. But if you have somehow missed it, the grading for the graded assignment, I guess there is a weightage of 10% of all. So try to finish it or submit. But if you're missing 1 and 2, that's totally like we are not expecting also to for 11 week. I guess if you'll just check the grading document, I guess you'll have to submit 9 or 10. Like if you're submitting all, that's totally fine. Like, but best 10 or best 9 out of 11
I
will
think
be
it's 5 out
counted.
of 5 out of 9.
Oh, 5 out of 9, then it's fine. Yeah. So I have not seen the grade because for some of the courses where like for the other diploma
It
courses,
is 10 out of 11, right?
I am not sure about that. You'll have to check the grading document for that.
Yes, 10 out of 11.
No, the grading assignment says it's 5 out of 9. Because 10 and 11 they are not taking into consideration for the.
Okay, then too it is 11 is there, no, up to 11.
When I saw the grading assignment, I see this up to 5 out of 9.
Let me share the screenshot just.
And so if we fell sick, then we don't have any leaves. So
what?
If we fell sick, then whatever the leaves and things that we'll really get, because if someone falls sick for weeks, then
No, then I don't know. Like you'll have to. Is it like, but there are some like if you're feeling sick, you'll not be feeling sick for like whole week, right? There's some chunk of like you have time, right? Like I guess for week 6 they have given you the content were released, I guess, before quiz itself. Now we have almost 15 days we were having for this week, right? So you have enough time if you'll just see that you have enough time to finish it up. Yeah, I can feel that the course like it is compact, but we'll have to somehow do that.
okay. So if
Yeah,
you even
this one is for
then still
eligibility. Yes.
Yeah, that will be
No.
for eligibility. Yeah.
Eligibility. I'm asking for the grading, entire grading for
Yeah,
10
for
percentage
grading it
weightage.
will be for grading it will be 10 out of 11.
That's what I'm saying.
Yeah,
Yes.
I have seen, yeah, that's what I'm saying. Okay, that's it's there in the same thing. The GA is
Yeah,
average
correct.
score 10 out of 11.
Correct.
Oh, I thought you were asking for this thing.
No. I'm asking for entire grading. Okay.
there should be something for sick because everyone falls sick.
No, but I think yesterday also somebody was asking in the discourse whether what will happen, because either of the quiz you need to attend to be eligible to write for the final exam. You cannot escape. You cannot skip both of them.
Quizzes, I guess you can skip, but again you'll be losing some marks. Like your marks will be counted out of 90. Yeah.
No, but Vishal, they say we have to write one of the quiz to sit for the final. That's what is the criteria, I think. See, eligibility to obtain the final grade, attending
You
end
have
term
to
examination.
write to write
one
the
of them.
quizzes. Yeah.
Either
Once
quiz one or quiz two.
once you're in the term students, like for the term student you can miss one, but again your final score will be counted out of 90, not 100.
Yeah, that's right.
There's like you'll be missing something. Yeah, if you are just missing the quiz paper, weightage will reduce. Correct. So there's different formula for the other people who is missing some quizzes. There's different formula for them to calculate the finals.
Sir, I have sent you my problem in your mail, sir.
I'll just forward that. Yeah.
Okay,
And the totally you said like 10 questions for a quiz to write in maths.
It will be 10 questions, but there can be some sub part of that. So altogether it will be 14 to 15 questions.
Okay, got it. So equal weightage of 25% from 5 to...
No, that's not, that I didn't say, but almost similar, but there can be some week, I guess 7th or 8th weeks has a good weightage because the concepts are like good there, like the calculus part, and the limits in the calculus, there are good weightage. the logarithm and inverse is much simpler, so you'll be having a less weightage from this two.
Okay, but in practice assignment, I can feel difficulties in all the
practice assignment. I told you,
no.
right? Practice assignment is like has
Yeah,
been
also,
made
sir.
pretty hard.
Practice assignment is hard of this logarithm function.
That is hard.
Yeah.
That's why I told you if you're not able to solve it, that's totally fine. But you should not be
Okay.
missing any of the previous term paper that you should be able to solve. Those are not that
Okay.
hard. Yeah.
Now got it. Thank you. Because wasting a lot of time here.
No, you try to solve it. If you're
Spending
not
most time.
also like we can solve it in the some of the session, but if you're not, you should not be like why we are not able to solve because some of the questions are really hard. Yeah.
Yes.
Sir, you mentioned about the discourse, right? If I try to log into that URL, it is saying I don't have access some IITM_pod access. Is it something I need to do to get access to that discourse link where I will post
So
my...
you this time you wrote the qualifier, huh?
Yeah, yes, sir.
So now you'll be getting in some time. You don't have the access now.
Okay, sir. Fine. Thank you.
Okay.
So I'll be informed through email something, right? That
You'll
my
be
user...
getting the mail ID and all. Like after that, you'll be able to access it.
Okay, fine.
Okay. Anything else? Any other?
So your email ID and
Yes, sir, I have.
Yeah, I have written in the
Discourse.
chat box. You should not like yeah.
So where it is?
Okay, I'll write it again. But I guess if somebody has that, you can just copy it and paste it.
Will you share this PDF in here, right?
Yeah, I'll share it on the
supplementary or here?
Supplementary content. Yeah, the same thing I have used while recording the content also, but that is in Hindi. Yeah, if somebody wants to go through, if somebody understand that, you can just go through that. I just explained everything in a similar like way, in a detailed way. Yeah. Okay, so if there is nothing, can we close it, or if you have anything?
Sir, I have a doubt in inverse function, sir.
Yeah, go ahead.
Sir, how to find, like, suppose if we have given any function, how to find that inverse? Can you explain?
I told you in the last session, I told you one method. Mostly it will not be asked for a difficult equation. If you have been asked for a simple problem, mostly it will be a very simple problem to calculate the inverse. The best method is to just swap the value of x and y. Just write it wherever it has been written x, you write it y, and calculate the value of y.
Okay, sir.
Are you getting me? See, there is a two-step process. Whatever the equation that has been written, let's for example, it is written y equals to x square. What did I say? Swap the value of x and y. So now your equation will become what? X equals to y square. Correct? Now you have to calculate the value of y. So y will become what? Y equals to root of x. So for
Yes,
x square, root of x is the inverse. Is it clear?
Okay, sir. Okay, sir.
Yeah.
Sure.
So this is how you calculate.
Okay.
Okay, so I'll just drop it off then. If you don't have any other doubts. Yeah.
Thank you so much for the session and information. Yes.
Thanks everyone for the coming to the session. Yeah. Have a good night and bye.
Good night. Thank you.